This is our last video on solving logarithmic and exponential equations. We're going to use the same steps we've been using, and this time we are doing when you have logarithms on both sides of the equation and only logarithms, no constant whole numbers. So, reminder, if you start with a logarithm, make sure you check your work for extraneous solutions. So once we're finished, we'll plug our numbers back into the original parentheses of all of the logarithms and make sure all of them are greater than 0. All of them are positive. If we have any negative logarithms, the whole thing is considered extraneous and not part of our solution. These are my favorite types of problems because they are the least amount of work. The only thing you need to remember, or the biggest issue that I see students forgetting, is to condense. They jump ahead to the second step, converting, which pretty much drops all our logs, and solve. So make sure you don't forget to condense. All right, we're going to solve the same way we've been doing. We have multiple logarithms. Actually, on all three of these are logarithms. We don't have to move this log over here to pair up with these because I don't have a +2 or some other kind of whole number added here. So I can leave it as is, but I do want to condense that left-hand side. So I'm going to write it as one single logarithm. I'm going to leave this one alone. And because it's a minus sign, that means I would write this as x plus 5 over x minus 3. And now what we're going to do is drop our logs. But really what's happening is we're converting. This is a common log, which means it's implied to have a base 10. So if I make this 10 raised to the log power equals 10 raised to the log power, over here on the left, my base 10 and my log base 10 cancel. And over here on the right, my 10 and my log base 10 cancel. So when you have logs everywhere, it's nice because your logs all cancel out. But before they cancel out, you have to condense them. Now that they're canceled out, I can solve this for x. I don't have anything to type into my calculator. I just solve for x. So I'm going to write this over 1 and cross multiply here. X plus 5 times 1 and x minus 3 times 2. I need to distribute my 2. And solve for x. So move all of your x's to one side of the equal sign. And add your 6 over to the other side. Before I can say that x equals 11 is my final answer, make sure when you substitute that 11 back in, 11 plus 5 is positive 16, 11 minus 3 is positive 8, and there's not an x here. If I sub it back into every logarithm, it's positive. Let's do one more example. Notice I have logs everywhere, so I'm going to be able to cancel them out when I convert. But first, I have to condense. So I'm going to rewrite that left-hand side as a single logarithm. The right side can stay natural log of 72. Because there's a plus sign here, that means I want to multiply what's inside my parentheses. And I want to actually distribute everything out this time. So distribute your y to the y and the minus 1. Y times y is y squared, and y times negative 1 is negative y. Now I have a single logarithm equal to a single logarithm, so I can cancel my logs, or I'm converting. Natural log has a base of e, so I'll make these both e raised to the natural log power. And my base e and my natural log, which has a base of e, cancels out. Let's solve for y in this case. This has a y squared and a y, so I'm going to have to factor. Get it equal to 0, which means subtract your 72 over to the other side, and factor. What two numbers can you come up with that multiply to negative 72 and add to negative 1? Set each one of those equal to 0. And these are your two possible answers. Check for extraneous solutions. If I sub a 9 in here, 9 minus 1 is positive 8. This would be positive 9, and that's 72 regardless, so 9 works. Negative 8 minus 1 is negative 9. We cannot have negative in our parentheses, so this one's extraneous. Last example. Let's condense this left-hand side. When we condense the left-hand side, because this is a plus sign, we will multiply what's inside their parentheses. Write it as a single logarithm, and it's x plus 1 times 4. The right-hand side stays as is. Okay, before we convert or drop our logs, let's simplify what's inside that first set of parentheses. Let's distribute our 4 to make this a 4x plus 4. Now I can convert, which means make this 3 raised to the log power and 3 raised to the log power. Because my base is the same on my exponent and my logs on both sides of the equal sign, everything all ends up canceling out. And I have 4x plus 4 equals x. Step 4, solve for x. So I want to move all of my x's to one side of the equal sign. X minus x is 0. And now solve for x. Subtract before you divide. Double check your answer. Make sure when I sub this back in, I still have positives inside my parentheses. So if I substitute in a negative 4/3 plus 1, that's negative 1/3. You can't have a negative, so this is extraneous, which means actually in this case, I don't have any other options, so this one is no solution. It's okay to have no solution. You don't have to substitute the negative 4/3 into the other logarithms. Since one of them failed, it just means the whole solution is considered extraneous. But if you did substitute it in here, you just have a negative 4/3, which is a negative number, and your domain has to be positive.